Okay, here's section 13.2. The last section was on linear measure. This one's going to be on area. So linear measure was one-dimensional measure. Area is two-dimensional. So we measure area in square units because area represents, two-dimensional shape, and it's all about covering the shape with non-overlapping squares that are all the same size. So, for instance, I drew same size rectangle, or at least I tried to make it the same size rectangle. This one though, so it's 1 yard by 2 yards. If I split it down the middle, then I have each one of these is what's called a square yard. It is 1 yard by 1 yard, or 1 square yard. The total area is 2. It takes 2 squares to cover that. If we look at this in terms of feet, we know that 1 yard is the same as 3 feet. So we have 3 going this way. 2 yards would be 6 feet. So we have 1, 2, 3, 4, 5, 6 going that way. That's a total of 18 squares. These squares are different size than these. These are the 1 yard squares. These are 1 foot squares. They're each 1 foot by 1 foot square. So the reason we're using this little 2 up here, this exponent, we call it a square, has to do with the shape of a square. Okay. The area is the same in both of these. The difference comes in which size or square or what unit we choose to cover. Now, a lot of people will mistakenly think that an area of 18 square feet means that it's an 18 by 18 rectangle, or in this case, square. Now, notice that only the unit is squared, not the 18. The 18 is the total number of squares. So it's 18 squares that measure, what size are they? They're 1 foot squares. So that's what the foot tells you. So 18 square feet means it takes 18 non-overlapping squares that are 1 foot by 1 foot in size to cover the shape. All right, so before we do a whole lot more in terms of area, let's take a small little detour and let's talk a little more about hands-on activities that can introduce areas before we get into all the nitty-gritty formulas and stuff. These things are called Geo Boards. Right, so what I did was I went online to mathplayground.com. They have an interactive Geo Board, so I just made this one and just kind of cut it out and taped it here. They do have an interactive little one where you just basically grab these little vertices and you can drag them and make all kinds of different shapes. So if you were to find the area of this figure, you would want to count the number of squares, right? So see right here, we have that square. There's a square. There's 1. So 4, 5, 6, 7 squares. 8, 9, 10, 11, 12, 13. That's not a full square. 14, 15, 16, 17, 18, 19. Full squares. Now we have a bunch of partial squares as well. Okay. So right here we have ourselves half of a square. Right here we have half of a square. There's another half of a square. There's another half, another one, and yet another one. So we have 1, 2, 3, 4, 5, 6, 7, 8 half squares. So that gives us a total of 19 full squares and 8 half squares. So of course the 8 half squares gives us 4 more squares to the 19, so that's 23 square units. You didn't have to count these up individually. You could have, of course, said, oh, well, this is 2 by, 1, 2, 3, 4, 5, 6. So you could count these in whatever way you want. But you can get little Geo boards for your classroom, and they just have like a bunch of little, almost like little pegs, and they come with rubber bands for the kids to stretch onto those pegs and to form a shape and then to find the area of the shape. Alright, so for this one, if you're finding the area of the shaded figure, rather than going through this and counting all of those squares, notice the white area is actually not that much compared to the blue, right? So how about we do this? How about we use subtraction this time? How about I find the area of the entire board and then I subtract off the white stuff. That'll give me the shaded region. So the area of the whole board, it's a 13 by 8 board. So there's the area of the entire board. And then all of this is the area of the white region. Now, where did I get some of this? This 1/2 3 times 6. So where did that come from? Well, right here, let's try to accent this. That rectangle, this white region right here, is half of a 3 by 6 rectangle. So this white region right here is half of a 3 by 6 rectangle, which is 18 squares, so it's half of that. This region right here is a 3 by 2. And then this region is half of a 2 by 10 area. So just so you can kind of follow, I'm going to color code this here. So we got pink, that area right there. Yellow, that region right there. And the orange. Is that region right there. So why did I add those? I said I was going to subtract. Well, because look closely, I got this subtraction on the outside of this. So I just added up the area of the white region and then subtracted it all at one time. I could have just as easily had subtracted each one of these. And yeah, the distributive property does say that that's going to be, each one of these is going to be subtracted. So we end up with a total of 79 square units. Okay, so let's talk about units of area. Just like before, we're going to have English units and we're going to have metric units. The English units of area are very familiar, right? We talked about inches, feet, yards, miles. Now we just have square inches. That's a 1 inch by 1 inch square, a 1 foot by 1 foot square. Those are usually, like, if you think about like floor tiles that you'll see, or like carpet squares, stuff like that. Those are usually 1 foot square. Sometimes they're 13 inches. But, that's kind of close to what a square foot looks like. Square yards, square miles. Then we have something new here, an acre. An acre is a unit of land measure. Okay, it doesn't have a square on it because it's only for area measure. Okay, you wouldn't say, oh, that room's about half an acre long. That doesn't make any sense. It doesn't measure one-dimensional stuff. It's just for area or land measure. So 1 acre is about 43,560 square feet. Now, frame of reference, that's about 1.5 football fields. The metric units of area are the usual suspects, right? It's all of these, but just squared from our stair steps in the last section. But we get some land measure as well. So similar to the acres, we have the hectare and the air. So I know this looks like it's the word R, but it's pronounced air. This is the hectare. Those are, again, units of area, so they're not squared, typically land measure. Just to give you a frame of reference, 1 acre is 100 square meters. That's about a 10 meter by 10 meter space. That's about a typical classroom size. A hectare is about 100 acres, 10,000 square meters. It's about 2 acres or 3 football fields. So I already said that acre, air, and hectare are units of land measure. Now, let's talk about converting. We already know how to convert using those conversion factors. Okay, from the last section, we know that to go from yards to feet, we use this conversion factor of 1 yard is 3 feet. But now we have to square that conversion factor, because now we're talking about square yards. Now this 2 out here is not squared, it's just the unit. In this conversion factor, we are going to have to square the entire conversion factor. So by squaring that entire conversion factor, we get this area conversion. That is, 1 square yard is 9 square feet. That makes sense, right? If it's 1 yard by 1 yard, that's 3 feet by 3 feet. That's 9 squares. So you can see how I highlighted that to show you how I squared that conversion factor. I'm still not squaring this 2. The square yards unit cancels, and I get 2 times 9 is 18, and my unit left here is square feet. Now, why is that not surprising? Because we're going to flip back here to page 1. Look, 2 square yards was the same as 18 square feet. It's like I knew that was going to happen. Alright, so let's get a conversion factor and see how to convert these 2. So this is a good opportunity to pause the video and try to work ahead of me. Alright, feet to inches. We know that there's 12 inches in 1 foot. So we need the feet to cancel. So we have that 1 foot is 12 inches, and I'm going to have to square that. So here's what we get. And if you want to jump straight to this step, that's fantastic. Okay? This would be 144 square inches is in 1 square foot. So all I did was square everything inside its parentheses. I squared the 12, got 144. I squared the inches, 1 squared stayed 1, and there's the feet squared. All right, so then we have 1 times 144 divided by 1. Square feet go away, so we get 144 square inches. $870 square feet, converting to square miles. Okay, so 870 square feet. Oops, bumped the camera. So 1 mile is 5,280 feet, and I'm going to need to square that. Come down here. So that's 870 square feet. Now why did I put the feet on the bottom? Because I'm going to cancel that. Don't cancel that until you square it. So that's going to be 1 square mile, because, you know, 1 squared. Ooh, 5280 squared. I don't know that one off the top of my head. Ooh, that's a big old honking number. You know what? I don't want to write that. So I'm going to write 5280 squared. Alright, we'll cancel those square feet. And then we just need to take 870 divided by big honking number. Ugh. Look at that. So I did, you know, 5280 squared, got, you know, big daddy number right here. I did 870 divided by that. You guys ever seen this before? This little e with the -5? That's scientific notation. That means it's 3.1206955 times 10 to the -5th power. So it's a super duper teeny tiny number. So here's what we get. So that would be what? 0.0000312 square miles. 870 square feet is not very big. So as far as square miles go, when you start talking about square miles, we're talking about like the size of a city. Okay? 870 square feet, that's like the size of a, I don't know, like a 2-bedroom apartment. So yeah, you wouldn't measure that with square miles. That's why that number is ridiculously small. Alright, how about square miles to acres? So let's go back here. And we have the acreage to square feet, and we know the feet to mile conversion, so we're going to have to use both of those. So we're going to use 1 square mile. We're going to convert this to feet. So 1 mile is 5,280. Why did I just put a little 0 up there? I didn't mean to do that. I meant to put a squared. I was distracted because I was upset at myself for making that too small. Square feet. Alright, so you can see that with this one, I went ahead and just put all the squares on there with that extra little dot that I didn't need. So that converts us to square feet. And then coming back, we have this many square feet is in 1 acre. So 1 acre is 43,560 square feet. Do I need to square 43,560? No. This conversion is an area conversion. It is already set up for an area conversion. This is a length conversion that we are making into an area conversion by squaring everything. Now, of course, that one is squared. I just didn't write, just didn't write squared there, but I can. So this was a length conversion that we forced into an area conversion by squaring everything. This already is an area conversion. So now my square feet are going to go away. And I'm going to, let's see, so we got 1 times 5280 squared times 1 divided by 43,560. Oh, that's a pretty nice number. I did not expect something quite that nice. But we get 640 acres. All right. So how about 1/4 of an acre is how many square feet? It's pretty common when you buy a house for them to tell you the entire plot of land in terms of acreage, even if it's a fraction of an acre. So it's probably going to be better for us. I mean, if you want to write that as 1/4, you can also write it as 0.25, whichever, it doesn't matter. So if you want to write 1/4 of an acre, and then we have our area conversion that 1 acre is 43,560 square feet. You don't need to square these. This is already an area conversion. Now notice up here, I put the acre on top, the square feet on the bottom. Here the square feet's on top, the acres on bottom. How do I know which way to do this? Well, I'm letting the units tell me. Here, square miles went away. I had square feet on top. So I needed the square feet on the bottom to cancel those. The unit that you're ending up with should be on the top. So my acres are going to go away. That's going to be 1 times 43,560 divided by 4. And looks like from our divisibility tests, that is going to be divisible by 4 because 60 is divisible by 4. So we get 10,890 square feet. All right, let's talk about how to convert area with the metric system. So remember our stair steps. Now with the stair steps, all we had to do was count. We just had to count how many place values we moved and in which direction we moved, and then we moved that decimal, boom, done. Easy peasy. This one is a little bit different because again, remember how we took these linear measures and we forced them into an area conversion by squaring everything? Well, what do you get when you square powers of 10? So if you did 10 squared, you get 100. 100 squared, you get 10,000. 1,000 squared, you get 1,000,000. So what's happening each time? When you square a power of 10, you double the place values. So 10 to 100, 100 to 10,000. So look, 2 zeros, 4 zeros, 1 0, 2 zeros, 3 zeros, 6 zeros. So you're doubling the place values. So the equivalent of squaring these is going to be to double the place values. So centimeters to millimeters is just one place to the right. So we know that 5 has a decimal point right here. So it's one place to the right. For linear measure, okay, that's for linear measure. This is area. So now I'm just screaming at you. So we're going to double that. So that 1 doubles to 2. So 1, 2. Decimal one's up right there. So we end up with 500 square millimeters. So the doubling comes from the fact that squaring these powers of 10 doubles those place values. So to convert metric units of area, we double the number of place values moved on the stair steps. I don't know why I didn't write this sooner. Feels like something I should have written. Watch, I have it written on the next page. No, I didn't. Okay, I just forgot. Okay, so 846 square meters to square kilometers. So let's go back. Meters to kilometers. That moves back 1, 2, 3 places to the left. So meters to kilometers is 3 places to the left. We're going to double that. So we get 846. There's my decimal point. So 3 places doubles to be 6 places to the left. So 1, 2, 3, 4, 5, 6. Decimal one's up right there. I'm going to fill in all those dips with zeros. I get my leading 0, 3 red zeros, 846 square kilometers. Square kilometers is like square miles. That's going to be like really big land measure. Whereas square meters is more like measuring like square footage, like measuring the inside of your house or inside of an apartment or classroom, things like that. Alright, so square meters to air. That's not acre. Acre is just ACRE. This is an air as in air and hectare. Alright, so let's go back and see what that conversion was. 1 air was 100 square meters. So 1 air was 100 square meters. This one we're not going to use the stair steps because the air and the hectare are not on the stair steps. So we're going to have to use a conversion factor for these, just like we did with the English units. Alright, so we have 1 air is 100 square meters. I don't have to square all of this. This is an area conversion. So I'm going to cancel those out, and I get 72 divided by 100, which is just going to be 0.72 air. Yep. So let's flip back here, see what the hectare conversion was. I don't remember that off the top of my head. 1 hectare is what, 100 air? I believe. I just want to make sure, yeah. So hectare is 100 air. It's also 10,000 square meters. So I think I'm going to use this conversion and go ahead and convert it to square meters and then convert the square meters to square kilometers. so this one's going to be really unusual because I'm going to have to use both the conversion factor and the stair steps. So that's why I picked this one. So 1 hectare is 10,000 square meters. Okay, so this is going to be 40,000 square meters. I still need to get it to square kilometers. So I'm going to need to use the stair steps. Now remember up here, when we went from meters to kilometers, we went 3 places to the left and then had to double that. So if we use the stairs, or the stair steps, meters to kilometers is 3 places to the left, and then because it's area, we're going to double that because it's square meters to square kilometers. So I'm going to take that 40,000 number and I'm going to move it 6 places to the left. 1, 2, 3, 4, 5, 6. That's going to give me my leading 0, decimal point 0, 4, and I don't need all those other zeros behind it. So this one we had to use the conversion factor and the stair steps. So I could see that one being really confusing for you because I had to use both. Your book would use a conversion factor here as well and say, okay, well, 1,000 meters is a kilometer, and then square that conversion factor. I figured I would just stick with my stair step technique. Just kind of stick with that and see if that helps. But if you find the conversion factors helpful for the metric stuff, then by all means use those. Okay, let's talk about the area formulas. The area formula for a rectangle. Area is length times width. Why is that? Well, you can see that in an example like this, 4 by 6, there's a total of 24 squares, right? Because it's 4 by 6. We know that that repeated addition there is how we can just simply multiply. The square, the area is the side squared. Now, this is just a special case of a rectangle where the length and width are the same, right? So it's still length times width. They just happen to be the same number. A parallelogram. Now a parallelogram, the area of that is base times height, right? So where this is your height, and then this part down here is your base. Why is that? Well, if you cut off this little shaded triangle and you move it over here, you form a rectangle. And this rectangle has an area of length times width. And that length is going to be that base, and the width is going to be that height. These two triangles are congruent. If you want to go for some congruence properties here, those two triangles are congruent by what? We could say, side, side, side. We could say side, angle, side, because of that right angle that's in both of them. But yeah, so that little technique is kind of how we can explain that parallelogram formula. A triangle, you probably know this formula. You've seen this one before, that the area of a triangle is 1/2 base times height. Why? Why is there a 1/2 suddenly in there? Well, because if we take this little shaded triangle and we make a copy of it, we flip it over and we put it right there. we form, look at that, a parallelogram. The area of a parallelogram is base times height. So base times height. So the triangle is half of a parallelogram. So it's just half base times height. Cool, huh? The trapezoid. That one's got a crazy area formula. Okay? It's 1/2 times the sum of the bases times the height. Because in a trapezoid you have an upper base and you have a lower base. And you have this height. So here's what we can do. If we take a trapezoid, I just took that shaded one, make a copy, flip it upside down, and stick it next to it. Very similar to what we did with the triangle, right? Because you see that 1/2, that's kind of an indicator for you, whispering little sweet nothings telling you that it's probably going to be half a parallelogram. So if we do that, we form, you guessed it, a parallelogram. Now look at this parallelogram though. It's got the same height as the trapezoid, but look at the base length of this parallelogram that's formed. Because I took a copy of this, flipped it upside down and attached it, this B1 is the same as this B1. This B2 is the same as this B2. My parallelogram has a length of B1 plus B2 and a height of H. So this is half of a parallelogram's area. Isn't that kind of cool? No, I love seeing how things work. That's always been something that's really cool to me. I love seeing how these formulas come about because it helps me to understand them a lot better. A regular n-gon. So the formula is 1/2 times the altitude times the perimeter. Okay? So we called this altitude R. You can call it, whatever you want to call it, but I think the formula sheet for this chapter calls it R. Now why? Well, here we go. It's all about some triangles in this case. I just used a hexagon, for instance. If you split this, the center, you split that into 6 triangles. Each triangle has that same base length because it's regular. So all these side lengths are the same. So we end up with 6 triangles, each having an area of 1/2 base times height. Now if you take this 6 times S, those 6 sides, each of length S, you get the perimeter. That's not just for the 6-sided figure, because however many triangles, well, it's going to determine it's going to be determined by how many sides you have. Circle, area is pi r squared. That one's not super duper easy to draw as far as why that one's the case. You can kind of extrapolate from this regular n-gon that has more and more and more sides, because the more sides that you get, the more circular this starts looking. So it kind of comes from that, but the sector of a circle is just a fraction of the total area. All right, so we've gone through all the formulas. Now it's time to use them. So let's find the area of these. So this first one here is just a triangle. It's very common to get area and perimeter confused. Okay, that happens a lot. Area is how much is inside. Perimeter is the rim. Okay. For this triangle, we know that the formula is 1/2 base times height. Okay, so we get 1/2. The base length is 10. The height is 4. These other two I just threw on there to distract you. So we get 20, and the unit here is square centimeters. So our units for area in this case are going to be squares. So it takes 20 squares, each centimeter by centimeter, to cover that. Okay. Looking at this triangle, this one was, had that nice little perpendicular. It was nice and oriented for us. This one's a little messier. Can you tell by that right angle that that 4 is your height? So really what I've done is I drew it this way to kind of throw you off, when really you should look at it this way. That's your height because of that little perpendicular, that right angle. And your base length is 2. This is 2 centimeters. So my area, again, is 1/2 base times height. So that's going to be 1/2 2 times 4, which is 4 square centimeters. All right, so I'm going to scooch these up. This shape right here is a parallelogram. So the area is just base times height. So pause the video and see if you can find the area of that parallelogram. Alright, so much like this one, the way that this is oriented makes a difference. So if you look at that parallelogram where this is your base, I'm trying to turn it that way. Here. Try like this here. So there's my parallelogram right there. I'm going to outline it because I'm having trouble seeing it, so I'm sure you are too. There's the parallelogram. The height of this parallelogram is right there. I'm going to draw that in pink. There's my height. There's that right angle. That's giving you that big fat clue. So my base length right there is the same as right there. So that's 5 centimeters. So my base times my height is going to be 5 times 8, which is 40 square centimeters. So I picked some of these, I picked one, of course, that was very obvious. But then I picked these because I felt like they were very, these were not very intuitive, and that these might trip you up if you see these. So that's why I picked those, because I feel like if I handed you some kind of plain Jane examples, that you would be able to handle those. All right, let's look at a trapezoid. Its formula is 1/2 the sum of the bases times the height. Well, the sum of the bases, looks like our bases are 8 and 2, but we don't have a height right here. So does that mean that we can't find the area? No, it means that we can find the area, we just have to find that height. We are given a lot of information here. We're given that 45-degree angles, which has got to mean something, right? Okay, so let's fill in some stuff. Let me grab a different color. So this is 2, which makes this distance right here also 2. What else do we know? Well, we know that that's a right angle. That's a 45-degree angle. So what is this angle up here? So looking at this little triangle right here, if that's 90 and that's 45, this has to also be 45, because the angles in a triangle always add up to 180. If this is a 45-degree angle, this is an isosceles triangle. That means that this side right here is congruent to H. So that's a 45-degree angle. That's a 45-degree angle. So we get that this side and this side are congruent. Now we can find these sides. These two sides are congruent to each other, and together they make up the rest of that 8. So if we take this 2 away, we get 6. Split that equally between these two, and each one of these are 3. So if we just take that 8 and we subtract 2, we get 6. And then if we split that in half, we're going to get 3. So this right here is 3, and that's 3. So this, I'm just going to put a little dark cloud over here just to kind of explain where I got that 3, so you guys don't think I just pulled it out of my butt. Because this is an isosceles triangle, that height is also going to be 3. Okay, so we get 1/2 the sum of the bases, 2 plus 8, that's the full base. We went through all that red and blue stuff to find that that height is 3. So now we can do that computation. So that's 1/2 of 10, which is 5, times 3 is 15 square centimeters. And lastly, circles and segments. The area of a circle is pi r squared. This is not the radius though. This is the diameter. So the diameter is 6 centimeters. The radius is half of that. So that tells me that the area is going to be pi times 3 squared. Remember, only the 3 is squared, not the pi. So we typically just write that using pi. You don't have to grab a calculator and actually multiply 9 times pi. Alright, last thing up is that segment. So this is a right angle right here. So this angle is going to be 90 degrees. The area, remember, was that angle over 360 times pi r squared. So this angle is right there, it's 90 degrees. So we got that 90 over 360 times pi. The radius is 4. So what is 90 over 360? It's 1/4 times pi times 16, which is just 4 pi square centimeters. I just happen to pick square centimeters for all this. You could pick any unit. Now, are you really shocked about that 1/4? You know, being that 90 over 360? Well, no, because look, that segment right there, that sector, is 1/4 of the whole circle. So if you didn't even use the sector formula, if you chose instead to say, oh, well, I can just tell that's 1/4 of the entire circle's area, and you just did 1/4 of pi r squared, that's just as correct. Okay, so that finishes us up for section 13.2.